All right, here we are with lesson 213, reasoning part 2. And again, please don't forget your course name and section number with all communication with me. Our objectives in this lesson are to write a 2-column and paragraph proof and to use the relationship between vertical angles to solve problems. Paragraph proof, a proof in the form of a paragraph. 2-column proof, a proof shown in 2 columns, the first column of which shows the steps, second column of which shows the basis for each step. And just an FYI, the paragraph, I'm going to do a proof, a 2-column proof in this lesson. The paragraph form of it is in the LMS. Okay? All right, let's review vertical angles. There are 2 non-adjacent angles formed by intersecting lines, and the sides of one angle are the opposite raised to the sides of the other angle. And in this picture, angle 1 and angle 3 are vertical, which means they are always going to be congruent. Angles 2 and 4 are also vertical, and they will also always be congruent. All right, I just wanted to show y'all a little lesson on GeoGebra. This is in your LMS, and the directions are quite clear on how to do this yourself. I went through and I did do them myself. The only problem I had was this green right here. Watch this. Let me see if I click on it. I thought if I right click, there it goes. You can go down to Object Properties. I'm showing you what mine looked like. Well, it's not doing it, but that's okay. Anyway, my green line covered all the angles. It started right here and went all the way around to this side. And that's not what you want. You want it to be a little slice of pie right here. Okay? So anyway, all I did was right click mine. I went to Object Properties under Basic, and it tells you this in your student guide instructions, except it tells you to click on something else, and that something else isn't here on this newer version of GeoGebra. So I just went in and clicked between 0 and 180 on mine. Let's see what happens. Oh, it stayed the same. And anyway, it fixed it. So I just wanted to tell you that if you take the time to do this in your lesson. But what's neat about this is you see any of these points that are blue. I don't think that one's blue, but these are blue. A, B, and C are blue. You can move it around, and you can see how the vertical angles change, and see how they're always congruent, no matter where I put it. They're always going to be congruent. Let's move C. Let's move C and see what happens. There you go. See how that works? And especially for you honor students who are working with your tessellations, it's good to go ahead and do these lessons that they have in the study guide with GeoGebra, because that's just going to help you learn the system even more for your tessellation project. Okay. Anyway, I just wanted to show y'all that right quick and let you see for yourself that by moving these around, we can see how the angles, the vertical angles, are always staying the same size, or congruent rather, not same size, but they are the same size, but I meant to say congruent. So there you go. All right, let me move this out of the way. All right, let's look at this proof. This is the proof, the paragraph proof of this is in your LMS. What I've done here is I've taken that paragraph proof and I've put it into a 2-column proof, because I want to give you lots of examples of these 2-column proofs so you'll understand how to do them when it comes time to do your test. Okay, here's our given, that angle 2 is congruent to angle 3, and see how they've marked up the picture for us, showing us they're congruent. What they want us to prove, this is our conjecture, by the way. Okay, that's our conjecture. What they're wanting us to prove is that angle 1 is congruent to angle 4. Angle 1 is congruent to angle 4. Well, we always start off in the beginning with our given. See, angle 2 is congruent to angle 3, and I've just typed in given here. Now, what we're going to go with next, because we're studying vertical angles, we're definitely going to be using those in our proofs. It says angle 1 and 2 are vertical. And what we've learned in lesson 12 and 13 is the definition of vertical angles. So that's going to be our reason. Now then, remember how I was saying your if is going to match your previous statement and your then is going to match your current statement? Well, I didn't do that here because I'm just writing a definition. But I have these highlighted pink and green for future statements. Okay? So if 1 and 2 are vertical angles, what do I know is always true about vertical angles? I know they're always congruent. Dun, dun, dun. So angle 1 is congruent to angle 2. And my reason for this is the vertical angle theorem that we've also learned in these last couple of lessons. And here's what the vertical angle theorem says. Now, when you're writing proofs, I would like for you to do this so you can make the connection. Okay? I've talked to you about this in our other lessons. But when you're writing your reasons on paper to turn in, like for a test, all you need to state is the vertical angle theorem. Okay, so it says if two angles form a pair of vertical angles, matches my previous statement, they are congruent, matches my current statement. Okay, so watch what I'm going to do here. Angle 2 and angle 3 are congruent, and angle 1 is congruent to angle 2, then angle 1 is also going to be congruent to angle 3. Now, there's probably two different properties you could use here, but I'm going to show you what the paragraph proof used. But look, see how I put down, I did that thinking? If angle 2 is congruent to angle 3, angle 1 is congruent to angle 2, then angle 1 has to be congruent to angle 3. That's how I came up with the fourth statement. Now watch this. Substitution property of equality. If angle 2 is congruent to angle 3, bada-bum, matches my previous statement 1, then angle 3 can be substituted for angle 2 in any expression. And that's what we did right here. Now, I'm going to think that if you had done this proof for a test and you had put transitive property there, I would have agreed. I would have agreed a lot. Okay? But both of them are going to work for this one. Okay, so next, angle 3 and angle 4 are vertical. Okay? I kind of went off all of a sudden. I was like, ooh, I'm not working with this anymore. This stuff. All of a sudden, I'm worried about angle 3 and angle 4. But remember, I'm having to prove angle 1 and angle 4 are congruent. Okay? So if I can prove angle 3 and angle 4 are congruent, then by default, 4 has to be congruent to 1. Okay. So, and again, I just wrote definition of vertical angles here. There's no other way to tell it. I mean, you can look at the picture. They're non-adjacent angles. Okay? Across from each other, where lines intersect, they're vertical. Okay, so on this next statement, if angle 3 and angle 4 are vertical, then what's always true? Bam, they're going to be congruent. So watch my reasoning here. Vertical angle theorem, if two angles form a pair of vertical angles, that matches my previous statement, they are congruent. Matches my current statement. Now, I can say with conviction that angle 1 is congruent to angle 4. And then, what makes me think I can say that? Again, the substitution property of equality. If angle 3 is congruent to angle 4, matches my previous statement, angle 1 can be substituted for angle 3 in any expression. And see how I substituted 1 for 3 in my statement? All right. So, again, if you had put transitive property there, I would have went for it. I would have said, okay, that works. All right, let's look at this. What is the relationship between each pair of angles and explain your answer? Well, this part A says angle TZW and angle RZS. So here's angle TZW, here's RZS. Now, what I did on this next slide, maybe, there we go, is I just put the little alpha and omega symbols in there so you could say, oh, those are the angles we're talking about. And of course, those look very vertical to me. I don't know about you, but they look vertical to me. But the relationship, whenever they ask you about relationships, that means they want to know, are they equal, congruent, or add them together to equal 180, things like that. So here's the relationship. Angle TZW is congruent to angle RZS, and the reasoning is they're vertical angles. Part B says, what's the relationship between angle WZS and angle RZT? And again, I put the little symbols in there so to help you see the angles. They're talking about this angle up on top. They're talking about this angle here on bottom. Okay? And again, those are vertical angles. So we're going to bet they're going to be congruent. And that's exactly what the answer key told me. That angle WZS is congruent to angle RZT because they are vertical angles. This example says find the value of x for each set of given angle measures. Part A says the measure of angle 2 here equals the expression 3x plus 5, and the measure of angle 4 equals the measure of 149 degrees. Now, angle 2 and 4, obviously vertical angles, so we know they're going to be congruent. The measures are going to equal each other. So if angle 4 is 149, that means angle 2 is 149. All right? But they want us to solve for x. So you say, well, Ms. Poor, how would I set that up as an equation? There we go. The measure of angle 2 equals the measure of angle 4, and I know this because they're vertical angles. So what I'm going to do next is a little substitution. I'm going to substitute measure angle 2 with 3x plus 5, substitute the measure angle 4 with 149. And see, this right here is called an algebraic proof. It's a two-column proof. Okay? Now I'm going to say, well, 3x equals 144, and this says what I did. I subtracted 5 from both sides of the equation. Then I'm going to be so bold as to say x equals 48. And all I did was divide both sides of the equation by 3. So there's my value for x. Part B says, find the measure of angle 1 right here and the measure of angle 3 right here. And the sneaky guys went ahead and gave me expressions for both of those. All right, so it's going to be a little tougher. Angle 1, I know is congruent to angle 3 because they're vertical angles. Okay, remember my next step is to substitute those angles with their expressions. So I'm going to have 4x minus 7 equals 2x plus 17. And then you remember what we do now? We get all the x's on one side, we get all of our constants on the other side of the equal sign. So what I did here was I subtracted 2x from both sides. So 4x minus 2x is going to leave me with 2x. Write down my minus 7, write down my positive 17. And this is what I did. Okay, now I got to get all the constants over to the right side of the equation. So I added 7 to 7, which is canceled out. Added 7 to 17, which gave me 24. So all I did was add 7 to both sides of the equation. and then I divide both sides by 2. 24 divided by 2 gives me 12. So the value of x in part B is going to be 12. Let's do one more. Oh, look at that. I didn't divide it all up. But I think y'all are getting the idea by now. But let me point out something to you. It says the measure of angle 3 equals 6x degrees, and the measure of angle 4 equals 10x minus 12 degrees. Well, look at angle 3 and 4. They're not vertical, okay? They're going to be a linear pair, and that's what I put right here. If I take the measure of angle 3, I add it to angle 4, I'm going to get 180 because that's our definition of a linear pair. Then I just do some substituting. I put 6x in for the measure of angle 3, 10x minus 12, I plug in for the measure of angle 4. That's called substitution. And then I just get busy combining like terms. Then I add 12 to both sides. Then I divide both sides. I add 12 to both sides. And then I divide both sides by 16. And 192 divided by 16 is going to give me 12. Okay? And that's my value of x. All right, what we talked about in this lesson, as you go through the reference guide and the LMS, you will be proving the vertical angle theorem, which states that if two angles form a pair of vertical angles, then they're congruent. And I showed you about using the geometry software. You should go through and try constructing this figure, okay? And all of this information right here is in the LMS, okay? But I just wanted to show you the what it looked like in GeoGebra, and there you can also, they give you a copy of the GeoGebra file, but they also give you the instructions to do it yourself in the LMS. Okay, there is no quiz for lesson 213, so you just need to be sure to read the LMS, read through the pages in the reference guide. Please, please, please complete these practice problems and come to me if you have any questions, or go to Toga, okay? And make note of any questions that you have when you attend CC on Thursday. And just remember, if you don't have a quiz, you still got to know the material because you're going to be tested on it. All right, we'll talk to you later. Thanks for listening.